Hello, everybody, and welcome to today's webinar presentation, Moving from a Relational Model to NoSQL, brought to you by Couchbase. I would like to introduce you to our presenters. First, Mark Gamble, who is Couchbase's Product and Solutions Marketing Director. Mark is a passionate product marketer with a technical and solution consulting background and 20+ years of experience in enterprise and open source technology. He has launched several database and analytics solutions throughout his career and has worked with customers across a wide variety of industries, including financial services, automotive, hospitality, high tech, and healthcare. With an expertise in analytics and AI, Mark loves all things data and is an emphatic supporter of Data for Good initiatives. And our second presenter today is Rick Jacobs, who is Couchbase's Technical Product Marketer Manager. Rick has varied backgrounds, includes experience at many of the world's leading organizations, such as Computer Sciences Corporation, IBM, Cloudera, and more. He comes with over 15 years of general technology experience garnered from serving in development, consulting, data science, sales engineering, and technical marketing roles. He holds several academic degrees, including an MS in computational science from George Mason University.
Thanks again, Drew, and hi everyone again. Mark here with Couchbase, and it's a pleasure to be here to talk about moving from a relational model to NoSQL. We're glad that you've tuned in, and we'll be discussing, of course, how Couchbase is the best option for the transition from an RDBMS, or relational database management system, to a NoSQL database. Among other reasons, because of its query model based on SQL, which allows you to leverage your existing RDBMS experience and expertise while working in the NoSQL paradigm. And as Drew mentioned, I'm ably assisted today by my colleague and good friend, Rick Jacobs. Rick, thanks for joining me today. Appreciate you being here.
Glad to be here, Brad.
And everybody buckle up, because Rick's going to show a live product demonstration towards the end of our program. So make sure to stick around for the whole thing. And with that, let's get started. First, we want to keep this at a high level. We're not going to go super deep, but we want to go over the methodology to migrate and run a relational database management system application in a NoSQL environment. We'll get a sense of the technical issues, considerations, and differences between the two technologies. However, we don't want to get mired in the details. We won't go into granular depth of things like query options or indexing. Rather, we'll stay at a higher level to give you a broad understanding of the concepts. So a quick peek at agenda. We'll start by giving a quick overview of NoSQL. What is it? Then we'll transition into an intro to Couchbase. What is Couchbase and how does it leverage and enable NoSQL? Then we'll talk a little bit about your options for migrating from an RDBMS system to NoSQL. Then we'll go into how to optimize. We'll choose an option, go through those steps, and then how do you optimize once you've done that migration. And then Rick's going to actually show us again the product live and living color. So first, a quick intro to NoSQL. When most transactions were offline and people browsed or met in person to conduct business, batching data and relatively low volume transactions were the norm. Applications could keep up, and there simply wasn't really the need for truly massive application scale in the in-person era. But now, especially within the last year, everything has moved online. This is adding strain to applications that weren't architected to handle that increased demand. These days, everything is online, and users look at hundreds of things before doing something like making a purchase. Supply chains are monitored and managed in real time. Where's my package? Where did the assembly line problem occur? And everything in the modern era captures and produces data. This drives volumes of both reads and writes way up on your database infrastructure. So enterprises have started turning to NoSQL databases to handle the increased volume more efficiently and with better scale. However, the first generation of NoSQL databases didn't do joins, didn't do SQL, didn't do transactions. People put up with them because they had to in order to meet performance and scalability requirements. but they did their real work offline on mainframes and relational database management systems. And now with business changing more rapidly, uptime requirements are increasing, reaching 100% uptime requirements, and everything moving online, the NoSQL architecture is even more relevant. Moreover, now you need to analyze in real time. There's no longer tolerance for taking the time to ship data to some other system, do some ETL, do some processing, and then do some analysis. Analytics needs to happen now in real time. That's why Couchbase, as a modern NoSQL database technology, supports SQL, joins, transactions, and an embedded MPP for real-time analytics. There's no need to bolt on these capabilities. Couchbase specializes in handling high data volume reliably and with zero downtime. The most common NoSQL databases use JSON documents to store and represent data. JSON is JavaScript object notation. It embeds key value pairs and arrays. And it can also embed sub-documents. This is an amazing concept that we'll delve into through the presentation. And this is a particular strength. It can also represent numbers and strings and Boolean values. JSON is supported by nearly every major language and platform on Earth and is the de facto language of modern services on the internet. So even if your database today doesn't support JSON, your application and application services are likely already speaking JSON. So it's a ubiquitous protocol. Let's examine what a JSON document is. It's most analogous to a row in a relational database management system. Different NoSQL databases have different storage paradigms, but a bucket is more like a database instance than a table. A relational table is most analogous to a set of JSON documents with the same type, which we generally concatenate as part of the ID. So I can essentially represent my relational tables on the left as sets of JSON documents, which we see here on the right. One thing to note is that while relational database management systems generally enforce constraints, NoSQL databases generally support agility or schema on read, meaning that I can add a field to a document or omit a field from a document. And there are various reasons that this is better, but it does mean that any constraint enforcement moves into the query or the application layer. Another thing is that that's different is that generally timestamps are either a string, array, or number. Conversion is handled at the query level. We really recommend using Epoch, the number style, or Unix time is another way it's known. All right, now let's get into, with that little primer, if you will, of NoSQL, let's get into Couchbase and specifically delve into why it's the best NoSQL technology for you to consider out there. To start, Couchbase is a distributed NoSQL database that delivers unmatched versatility, performance, scalability, and value across cloud, on-premise, edge, and hybrid deployments. When we consider how Couchbase is different from other modern databases, there are really three key areas where we win with our customers. First, in agility and flexibility for developers. Couchbase accelerates application development by capitalizing on a ubiquitous query language, SQL. It offers full text search, adaptive indexing, along with seamless data synchronization, all as core features of the software. Customer studies show that these tenets enable a 20% faster development cycle for applications. Next, Couchbase offers predictable performance at scale, particularly appealing for IT architects. The server can handle any volume, volatility, or speed of data, any number of sources, and any number of end users with an in-memory dataset process, smart optimization, and highly performant indexing. Customers report that their applications show a 10 to 20x better performance on Couchbase. Amazing, amazing numbers. And Couchbase is the easiest platform to manage for DevOps. Couchbase helps you streamline setup and configuration, take advantage of multi-cloud agility, and helps ensure availability with the coveted 5 nines. That's 99.999% reliability and uptime. Customers report 37% more efficient database management and a 14% lower database licensing costs using Couchbase. Couchbase supports transactions, SQL, and full-text search. It's a memory-first, shared nothing distributed architecture. What this means is that the default behavior is that you can read or write from any node. The write will be put into memory and replicated to at least one node, and it will be written to disk later, and this is entirely configurable. And your application then moves on. If any node goes down, your clients don't care. They don't have to. They just connect to a different node. Data reliability is assured through replication. I want to make sure everyone gets a sense of how also SQL on JSON works. So here's a few examples where you see an insert statement or creating an index, a select and a delete. These are just examples of N1QL or NCL as we call it. NCL is Couchbase's query language modeled on and just as easy as SQL. Couchbase Server is the basis of our value. But don't just take my word for it. The readers of Database Trends and Applications have voted Couchbase as the best database overall in this year's DTBA Readers' Choice Awards. Couchbase also won the Best in-Memory Database category for the 3rd consecutive year. We also received finalist distinction in the categories of Best NoSQL Database, Best IoT Solution, and Couchbase Cloud makes its debut on the annual's Reader's Choice list as a finalist for Best Cloud Database. We're really honored to have received this recognition, and it speaks to the value that customers get from the technology. Couchbase runs on-prem, in your own cloud, across multiple clouds, or you can take advantage of our fully managed database as a service offering, Couchbase Cloud, which offers a free trial so you can try out your migration and see for yourself how easy it can be. We're going to focus, of course, on Couchbase Server today, but Couchbase also supports edge computing with an embeddable database and a gateway that allows local, peer-to-peer, and client-server edge applications. This model enables resilient apps that maximize uptime and minimize latency, whether this is at a big box store or on the factory floor. It's a simple fact. If your connection to the cloud is lost, your applications go down, you suffer business downtime. Only Couchbase supports a distributed cloud-to-edge model that moves data and compute closer to applications, guaranteeing uptime and eliminating latency. Whether you're in the cloud or deployed across a set of data centers, Couchbase supports high availability through replication and disaster recovery through cross-data center replication, or XDCR. This lets you support multiple data centers or multiple geographic zones in the case of cloud. The feature is highly configurable to allow for the optimal balance of replication based on any given use case. And in essence, you gain the ability to read and write locally and have the right data go to other geographies through replication. XDCR is highly performant, independently scalable, infrastructure agnostic, topology aware, and resilient, and it helps meet the availability requirements for any application. Most applications that go to NoSQL are greenfield, they start there. But we've been seeing more and more migrations recently from relational systems, and there are a lot of reasons for this. The number one reason in our experience is that there's an application, it works, but now has to scale. Now there are new demands that the app was simply not designed to handle, whether it's because of a cell provider wants to give users more visibility into their data usage by making an external service remotely available, or perhaps a retailer that suddenly has a lot of online orders, or a financial services firm that has increasing data volume and is pursuing a more service-oriented and consolidated architecture. Each one of these are valid examples, and they follow a general pattern. Lots of change happening more rapidly, and the need for more reliability and more scale. When we strategize a move from relational to NoSQL, we need to think about some things. What level of risk are we willing to tolerate? What skills and expertise do we have in-house or do we have to acquire? What's the cost of migration? And what are our performance and scalability requirements? There's really different options we have when pursuing migration. This visual depicts the options on a scale from highest risk and effort to the lowest. So first, do we want to rewrite the whole application? It's a lot of effort and a lot of risk, takes a lot of time, but it does give an opportunity to achieve the most optimal performance and scale. Another option is to migrate the database and totally rewrite the data layer in the application. A little bit less effort, a little bit less risk, but still enough to be a consideration. Performance and scale is probably almost as good as rewriting here. Another option is that we can keep everything as is, but refactor our data, logic, and relational schema into a best practice schema. We're keeping our business logic in this option and most of our data logic, but pursuing optimization up front. That's right around the middle of the effort and risk scale. Number 4 is we can optimize later. This is probably one of the better options, and we've seen this most commonly taken up. Basically, migrate table rows to documents and make as few changes to the queries as possible. Initial performance and scale may not be as great as you might hope, but it will work, and it is low risk, and it gives a basis upon which to optimize once migration is complete to gain those performance boosts. And finally, at the lowest risk and effort, we could just not bother optimizing and host it. So we're really balancing performance and scale with our effort and risk. Generally, we see organizations doing more of an option 3 or 4 than an option 1 or 2. And option 5 is typically only done for applications that are migrated simply for consolidation reasons, where performance and scale requirements are not as high. So we'll drill into option number 4, migration without denormalizing. And this offers the best balance of quick migration with low risk and effort. And then we'll explore optimizing post-migration. So how do we migrate without denormalizing the data into a big document? First, we need a NoSQL database that supports SQL, ACID transactions, and joins. We need to understand how the tables and rows relate to documents. There will be SQL dialect transitions similar to when you go between two RDBMSs. You know, even if an RDBMS officially supports a given ANSI standard, we all know some changes are always necessary when moving from one repository to another. Once we get everything running, we want to consider optimization afterwards because we might not see the initial performance improvements until we optimize. We need to expect that up front. When we move to a distributed architecture, there's a different sweet spot for performance. For Couchbase, the key value lookup will be faster. The query that hits a lot of rows will be faster because we can pipeline it from multiple servers at once. So real performance improvement over your original application comes with that optimization, which we'll discuss a little bit later in the presentation. So let's look at how things relate between your relational system and Couchbase. A set of like-typed fields are analogous to a table. Here we see a relational table on the left and a JSON document on the right. Notice the JSON document has a type, and the type is also included in the ID. The user document type is analogous to a user table in a relational database. A given document, an individual document, is analogous to a record or a row in a relational system. Like named fields in a document set are analogous to a column. So you're starting to hopefully see the parallels here. A conventional relational model tries to have minimally redundant data. This minimizes storage, enforces a schema, and handles joins in memory on a single server. It also requires multiple transactions to piece together information across tables, whereas in a JSON document, the related information is encapsulated in a given document or record. The relational model separates the detail and so requires more work to knit them back together. A document is fairly denormalized. It generally aligns with how your application uses the data. Normal single document reads and writes don't require transactions in Couchbase. This means fewer joins and fewer transactions, which in short scales better horizontally. For Couchbase, we query on a bucket. Remember that a bucket is more like a database instance than a table. And what gives us the specificity of a table is that we specify the document type. So these are two queries that essentially do the same thing. On the left, we see the relational query. And on the right, we see the query on Couchbase against JSON documents. Notice that they're almost identical. So you can, again, leverage your existing SQL expertise to work with data on Couchbase. And remember that a relational table translates to a document type in a bucket, and any bucket can store documents of many types. ANSI joins and other SQL conventions are supported, but there are also constructs in NCL that are mainly about working with the extra richness of detail that a JSON document can store above a relational data row. You'll see things in NCL such as unnest or nest. This is for working with extended information within documents such as arrays and child objects. When you create an index, the meta keyword allows you to refer to field names. And global secondary index is called out in this example, but other index types are supported. For the sake of time, we won't get into the details of indexing here, except to say that they are an integral part of the Couchbase model. So hopefully I've made it clear, and we now understand the parallels between relational data and JSON documents. And let's say that we've used this knowledge to move our data into JSON, and it's now hosted on Couchbase. Our one-for-one relational model is mimicked in NoSQL in this case. So now, how do we go about optimizing it to take full advantage of the NoSQL performance benefits? Well, here's our key considerations. The first consideration is that joining and transacting is costly in a distributed environment. It doesn't scale as well horizontally. Since JSON documents can embed related information in the construct of a record, consider minimizing joins by eliminating disparate tables and incorporating the detail directly to the record itself. Next, your well-designed application code is a guide. Use it. And I say well-designed here because if your application works great today, it will continue to work great on Couchbase, only more performant. But if it's not working great today, it probably won't improve by moving it to a new backend. So really, it's upon the developer to make sure the application code is well designed, and then that can serve as a guide. So if in your, for example, if in your application person contains addresses, but looks up orders, that's a good hint that the addresses should probably be stored in the person document type. But you might consider another document type called orders to handle that data. So the summary here is by examining your application code, you can start to make these inferences that will inform your optimization strategy. Another consideration is thinking in terms of entities. when planning a relational schema, we think in terms of flattening the data and reducing redundancy. But instead, think of the schema in terms of entities. In the scope of your application, does this entity have a life cycle outside of the thing that always references it? Because that can help inform how you optimize. Also, can you reduce the number of explicit transactions and joins required? When trying to optimize, we should always strive to reduce joins in most cases in general, where it makes sense and where it will have definite impact on performance. And lastly, this one's actually seems like a minor thing, but it's actually really important. Have you met your performance and scale requirements post-migration and during optimization? So that begs, of course, that you have performance requirements in mind. So if you begin optimizing and see acceptable performance meeting those requirements, your optimization is complete. You don't need to continue optimizing because optimization can always go on forever. So once you meet those performance requirements, you're done. So make sure you have targets in mind for performance that you can test post-migration. Let's take a look at reducing transactions. On the left here, we have a relational transaction. We're updating a savings account table and updating a checking account table, multiple actions on multiple tables for just one update. And on the right side, we see the nickel equivalent, where we've put these elements formerly stored in separate tables together into a single document type called account. This gives us the ability to do one update across all accounts without the need for multiple transactions. In fact, since it's on a single document, there's no transaction. We perform the updates on the same document. This is a very simple example, but I think it nicely illustrates the concept of optimizing your model. As a best practice, we want to emphasize, use your logical model to guide your optimization. Use your objects to determine what to embed. So in this case, this is a logical model represented, and we have a given order, and the order has multiple items of various quantities. Separate tables in relation, but JSON allows us to embed the details within a document. We can actually put these elements of items and products into a single document, reducing the number of document types or tables in the RDBMS nomenclature. Here we're depicting how pay type can be embedded into the order, which then refers to items, which embeds product. Again, leveraging this depiction of the logical model to determine the best embedding options for optimization. We can also leverage references. Products have a life cycle independent from the order. So we may embed the ID of the product and related quantity, both in the order, but store the product details in a product document type. In this way, we can just reference the product from the order without the need for an intermediate order items join table, because the item quantities are embedded or stored in the order document type. So hopefully you're starting to see how optimization can be achieved by leveraging these principles of embedding and capturing that extra detail and richness into a single record within JSON documents. And here we see an example of embedding within JSON documents. What do I mean when I say that? Well, we have here on the left a child object and on the right an array. So the difference is that on the left, the child is that we see here is of the phones object, where there's a home phone number nested under the phones field. On the right, we have an array where multiple values can be nested under the phones object as multi-value containers of information related to the core object. So this ability is one of the keys to the JSON model's efficiency, where table joins are eliminated by adding extra detail directly to each and every record. So some conclusions on migration before we get to the demonstration. Number one, reduce risk and make your life a little easier by migrating first, then optimizing post-migration. Number two, strive to reduce joins and transactions on your optimization exercise. Number three, leverage embedding to reduce document types and thus joins. Number four, optimizing can reduce the need for ACID transactions, increasing efficiency. And number five, lastly, when optimizing, again, we want to really state this, have performance goals established. And when you hit the goal, stop optimizing, you're done. This is because optimization, again, can be endless. And when performance goals are met, let that be your sign that your optimization is complete. As we transition to the demonstration, I'll once again remind everyone that Nickel, Couchbase's query language, is analogous to SQL. This is one of the main reasons, in fact, that developers turn to Couchbase when going to NoSQL. They can continue to leverage existing code and expertise for their applications while at the same time realizing the efficiency and benefits of a JSON-based key value data store. So NoSQL is the way to go, as long as you can query it with SQL and take advantage of all of the other features of Couchbase. So with that, I'd like to turn it over to my esteemed colleague, Rick, and I will change presenters and we'll see what the product looks like in action. So with that, Rick, the floor is yours.
Thank you very much. All right, let me know when you can see my screen, Mark, if you don't mind.
I can. Yes, I can see it clearly.
All right, great. So again, first of all, thanks again for everyone on the line for taking the time to attend this webinar. My goal in following Mark's great presentation is to show how easy it is to interact with data in Couchbase and how similar it is to relational databases. So I will go through some of the Couchbase UI features. I'll look at a query comparison between Couchbase and one of our top competitors, and then I'll do a quick review. So that's the basic agenda for this demo. Again, we'll look at the Couchbase UI. I'll look at buckets, creating a bucket, creating an index, querying data in Couchbase, using that data via code, and also visualizations, and then a quick summary. All right, so let me show you the Couchbase UI. So when you log into Couchbase, you'll be met with a UI similar to this. Basically, this is the dashboard for the Couchbase cluster. It shows you things like the buckets that are installed on this particular cluster. You can go into the security tab and add users. You can also query the data. What I want to do first is look at some of this data that's currently in the cluster. So I'll go to documents, and then here we can just take a quick sample of some of the data that's in this particular bucket. The bucket that I really wanted to focus on is the COVID bucket. This data is old. It's basically data that I've had in there for a few days. So to prove that this is old data, I'm going to run a query based on today's date. So the point of this query is, number one, to show that the data is old. So I should get no results for today's date. And then more importantly, to show the SQL syntax that's used to query Couchbase. So as expected, we got no results back. But the point was to show the query syntax that's used to query Couchbase, which again is very similar to folks to the queries that you would run on a NoSQL database. I am also going to go back and delete this COVID data cluster because the data that I want is based on today's date. So again, that cluster contains some old information. I'm going to go ahead now and rerun the upload of that data into Couchbase, but as of today. So I've got a Python script, which I won't bore you by showing you, that goes to the COVID site, downloads that data, and adds it to the Couchbase bucket. So first thing I have to do is add a bucket called COVID for this new COVID data. That's pretty fast. The COVID bucket is now in place. And now I'm gonna run the code to load that data. All right, so once that code runs, we should start seeing information in that bucket. And then once that data is in the bucket, we can run that query again based on today's date, and we should get results this time. So we've got the bucket. If I do a refresh, I should see some data loaded. All right, this is what happens when you run things live. So in order to get access that data, I do need to create an index. So I'm gonna go ahead and create that COVID index now. And again, very easy to create an index, basic SQL syntax. All right, index created. Now let's run that query. So the data should be loaded in that Couchbase COVID folder. Give me a second while that code runs. All right, and we have 11,000 records just added to that COVID folder. Now I'm gonna run that query, take a look at that data. Let me do a select on that COVID bucket and just see the data that was loaded into that COVID bucket. So for all you database folks on the line, I'm doing a select star, which is not recommended in relational databases. All right, so we know we have data in that COVID bucket. And we know that we had deleted that bucket before, and now we have data in that bucket. And we can access that data through very simple SQL queries. One of the things I wanted to do was analyze that data to see the debts and recovered so far. So I'm gonna go ahead and run a query to do that. All right, so I'm selecting confirm debts recovered and by end state from that COVID bucket. And then I'm doing a limit by 5 so I don't get too many results back. So pretty quickly, we've got some results back based on the confirmed debts recovered and the state from that COVID data bucket, data source that we just added. So we deleted the bucket, we added data back into that bucket, and we're showing how we can query that bucket. The other thing I wanted to show is how easy it is to access Couchbase data from outside of Couchbase. So for that purpose, I've got some Scala code, which I'm gonna drag over to my main screen so you can see that. This is pretty simple stuff. All it does is connects to that Couchbase bucket. It's connecting to one of our sample buckets, the bare sample, and then it runs a query. So I'm gonna go ahead and trigger this. This is from my laptop reaching out to the Couchbase cluster, analyzing that bare sample bucket and running a simple query on that. So this is just getting the different types in the bare sample bucket. So I'd like to note that on a development cluster, this is going to run a lot faster. This cluster is sitting on my laptop, and the Scala data is also on my laptop. So there's a bunch of backend processing that's going on all from my little laptop. All right, so we've connected to the cluster and we should see some data come back. It's a very short query. We're really only looking for 2 values. All right, here we got them. The data that's returned from that query is the data type beer and the data type brewery. So as you can see, we ran this simple query, select type from the beer sample bucket and then group it by type. I'm going to copy that same SQL statement and run it from the UI so that we can prove that it's the same code that's being run. So same statement now being run from the UI. Much faster. So we've seen we got back the types of brewery and beer. There's different views that we can look at that data. We can look at a table view, which is very succinct. So now I've got the data types brewery and beer based on that query that I ran. The other thing that a lot of analysts are very interested in is connecting BI tools to a backend data repository. So a data repository like Couchbase, but with a BI tool on top of it. You can do that in the Couchbase environment. It's actually also pretty simple, very similar to what you would do with databases. And here I have an existing Couchbase connection to that COVID data from Tableau. So I'm running an update on that data. Tableau is going to go out and grab that data again, refresh it. And it's a direct connection between Couchbase and Tableau to allow analysts to visualize their data. What I have here is a Tableau dashboard. Pretty simple. What it does is it looks at the debts and recoveries by state, and it's based on different dates. So I'm going to go ahead and look at yesterday's date, which is the most recent date we have. And this is what was reported yesterday. So these are the debts and recovery numbers from yesterday. So again, the main point of this demonstration wasn't necessarily to show, Tableau as a BI tool, but to show how easy it is to interact with data that's sitting in a Couchbase cluster, whether that be from the queries that we showed earlier or from, a tool like Tableau. So to wrap up, I'll go back to the presentation. Here I'm going to show a side-by-side comparison between Couchbase and one of our leading competitors, MongoDB. And as you can see, the Couchbase query looks very much like regular SQL. So it's N1QL, which is the Couchbase query language, but it's basically SQL. So we're running a select, joining to 2 different buckets and analyzing and doing a group by on the data that comes back. Whereas in Mongo, this is somewhat difficult to understand. Most of us on the line are probably somewhat familiar with SQL, and this makes sense. This is somewhat difficult to understand because it's a proprietary language that very few people are going to be familiar with. And now to summarize the presentation, I want to do a quick review of kind of what we've seen so far. So we looked at the Couchbase bucket creation, which again was very easy. We deleted that COVID data and brought it back. We looked at creating an index, which we need to query the data. We looked at some select queries and some joins. And the point of this demonstration is really to show that Couchbase is a much more, it's a database that's much more flexible, it's cheaper, and it's easier to manipulate the data within the Couchbase database, whether you do that from the UI or you do it from code or you do it from a BI tool. And as Mark mentioned before, this has been independently confirmed by companies such as DBTA, who named us as the Reader's Choice #1 database for 2020, and also organizations like Alturas, who've done comparisons between Couchbase and our top competitors and found us to be the best performing. So again, thanks a lot for walking through this live demo with me. And again, feel free to ask any questions.
Excellent. Thanks, Rick. Appreciate you bringing the product to life. As Rick transitions back over to me, we want to encourage everyone to ask some questions. We see a few coming in. And Rick, if you can pass the presentation back over to me.
All right.
And we'll get into some Q&A and a little bit of wrap up. All right. So thanks again, Rick, for showing us what it looks like. Super easy. Want to double down on the fact that you can leverage your existing knowledge of SQL to work with JSON data in Couchbase. This is a unique distinction, as Rick really nicely pointed out with that side-by-side comparison. You can come in with your existing select statements and queries in your application, and with a minimum or almost no updating or modification, they will continue to work against Couchbase. Whereas in Mongo, you have to learn a new query language before you can even start to change the back end of your application. So big considerations and great reasons why Couchbase should be the #1 choice. We want to encourage everyone to go to couchbase.com and sign up for a free trial of Couchbase Cloud. This is our database as a service. Go to couchbase.com/products/cloud and take advantage. You don't even have to bother installing anything. Just sign up for the free trial and you can get started testing out your migrations right away. Also, don't forget to secure your spot at Couchbase Connect online. This is a virtual conference for developers. We'll be announcing new product capabilities. We'll showcase best practices and offer countless opportunities to learn about Couchbase products. So make sure to register today. That's coming up in just about 3 weeks' time. All right, with that, let's open the floor to a few questions in the short time that we have left. And Rick, there's a couple here. I think maybe what we'll do is sort of divide and conquer, but I'll read them out and we'll see if we can get through a few of these. Any that we don't answer before the end of the program, we will follow up via email after the event. So question #1 here from Raj. Does Couchbase offer consulting to assist with migration? Great question, Raj. Thank you. Yes, Couchbase has a professional services organization staffed with experts to assist with all things Couchbase, including migration. So there are things like quick start packages. These are packaged engagements that are designed to fit any budget. And they're staffed by experts whose goal is to usher customers to self-sufficiency. We're not a consulting organization. We sell software. We have experts that we want to come in and make you self-sufficient. We don't want to park a consultant for the next 6 months or year at your company. We need them for other engagements. And so we've specialized in making our customers self-sufficient as quickly as possible. So yeah, you can learn more on couchbase.com for sure. Question #2 is from Kim. Rick, maybe I'll toss this your direction. Kim asks, is Couchbase useful for machine learning use cases?
Oh yeah, thanks for that question, Kim. That's actually an area that I'm personally pretty interested in. So yeah, Couchbase does offer support for ML use cases. We've got a bunch of SDKs for all the major languages, including Java, Python, Scala, all of the web languages. So yes, we offer interaction with ML packages, and you can also use the connection, the Couchbase connector, like I used with the Tableau demonstration. You can also use a JDBC connection for front-end ML applications such as RapidMiner, which I use personally, and AutoML. So you can interact with Couchbase via code from the major machine learning languages via the SDKs, or you can also interact with Couchbase directly via a JDBC connection to one of those UI type, AutoML type machine learning applications.
Great. Thanks, Rick. Yeah, questions are coming in fast and furious here. So let me maybe toss another one your way, Rick, from Jeff, who asks, how are companies using Couchbase for field services at the edge? So an edge computing question. You want to field this one?
Sure. So Couchbase has a pretty extensive mobile platform. We've got an actual database, Couchbase Lite, that can run on edge applications and then sync back home to the Couchbase server as needed. And then we've got the sync database server that is the interaction between that front end Couchbase Lite application sitting on the edge device and then the Couchbase server at home. So we've got a sync gateway in between those two portals. Again, very, very established mobile solution that we've had for several years, unlike some of our competitors that are just getting into that space.
Great. Probably time for a couple more here. Madhu asks, does Couchbase support streaming data or big data? I'll take this one at the high level. The answer is yes. And when you might recall in the presentation when I talked about Couchbase supporting and actually offering an MPP analytics engine, this is what enables that. So MPP, massively parallel processing engine, analogous to what you find in other solutions like big data solutions like Netezza, for example. So the answer is 100% yes. It is a separate engine from the Nickel engine, but leverages the same query syntax. But it's designed, of course, to handle massive amounts of data specifically for analytic use cases. All right, let's look at another question here. Manoj asks, can Couchbase handle blob data for content management? Wow. So there are real DBAs and database folks on today, we can tell. First, let's remember that Couchbase is not a blob store. Blob, of course, being binary large object for things like media, video, things of that nature. So Couchbase is a memory-based document store. It's not a blob store. That said, we've been asked the question many times, and in fact, there are techniques for storing blob data on Couchbase that involve chunking the data and referencing it. In essence, storing the blob data in one bucket with references to the blob data stored in another bucket. And the technique works really well for customers. And there's actually a blog out on blogs.couchbase.com detailing how to set it up. I recommend everyone check that out. It's by our colleague, Cecile Lepop. And she wrote a whole blog outlining how you can take advantage of Couchbase for managing blob content. All right, maybe we'll do one more and then get everyone back to their busy day. Madhu asked another question. How does Couchbase differ from other open source NoSQL products? So hopefully, Madhu, we've made the case. There are, of course, many. But one of the top things that we find against all competitors is that we outperform. Rick mentioned our independent study from the organization called Altoros. And they evaluated Couchbase in a performance scenario, measured performance scenarios, and Couchbase won against Mongo, Cloudera, and all of the other popular NoSQL databases out there by huge margins. That study is or will be available shortly on Couchbase.com. And the other main difference we talked about is the analogies of working with the data in relational system to working with the data in Couchbase, because you get to use familiar constructs of a relational system like SQL and joins and take advantage of that you cannot do in other NoSQL databases. They simply don't support that notion. So these are main differentiators for us. So with that, I think we'll have to wrap up for today. We thought we'd be done a little bit early, but we're taking it right up to the hour. I want to thank everyone for joining us today. Want to thank Rick for showcasing the product. And with that, also don't forget to join us at Connect Online, and I'll toss it back over to Drew for some wrap up.
Awesome. Thanks, Mark. With that, DZone would like to thank both Rick and Mark for a great presentation. I would also like to thank Couchbase for providing the audience with a great webinar. Lastly, thank you to everyone who attended today. DZone hopes you learned something new that will help you in your developer career. Thanks and have a great day.